different things to different people. It's okay if I step over here, right? Okay. So let's talk about what these things are. So like, what does productivity mean to you in way of whatever it is that you do? Okay. Actually, we'll get to that in a second. But okay, from your perspective, what you do totally makes sense. Okay. Stability. Nobody wants the damn thing to go down, right? Okay. Performance is obvious. The user clicks on something, you just want it to do something really quick without, waiting. I was kind of thinking in your domain, it's here more so than here, because this, productivity usually has the connotation of developers are able to produce and spit these sort of sprints fast enough, but there's a little bit of that in terms of agility. But okay, resiliency. So this is it's sort of the question between resiliency and elasticity. Anybody guess what that difference is? Very good. Perfect. Okay, perfect. So resiliency generally means something goes down, you're not dead in the water, which is a little bit different from stability, because stability means, the implication of stability is you don't do it to yourself. Like the database application logs get full and the database stops, okay? It's just a little bit of difference in that regard, but the end result is sometimes the same. And then we don't have to cover security and maintainability because those are relatively obvious. So if those are what sort of make up what technical debt is, let's talk about what it's not. So some level of maintenance. Every application, every tool, everything you have requires somebody to do some unsexy work on it from time to time. It just is a fact of life. And so that by itself is not technical debt, up to and including things related to security, like you use Java, you might have to patch it from time to time. It's just work that you have to do. So that by itself is not technical debt. Insufficient processes. Yeah, they could lead to a technical debt, but generally speaking, for example, you guys are being in CI/CD pipeline-ish kind of a deal. So if you have a weak pipeline, that by itself is not technical debt per se. And we'll get to that in a minute. Design corrections. So the UI that somebody designed didn't work out. Yeah. Okay, that's not technical debt. It's just life. It's just software. And then here's the interesting one that there's a lot of debate around, which is if you outgrow your solution. You start, for example, with a SQL database, okay? And then over time, as the application grows and as the usage changes, then you determine that, you know what? I need to be able to look at a bunch of data across a series of time over perhaps the course of 10 years down to the second. A SQL database is the most horrible choice for that option. Okay. There are better options like time series, so like in AWS has time stream, for example. So every once in a while, you might have to decide, hey, you know what? I outgrew the solution that I had based on the trajectory of my app and my workload. I might have to port the data or port to something else. So that by itself is not technical debt. Any questions at all? Yes, sir.
Well, okay, so how do you classify that? So my background as a DBA, we've outgrown applications where we started with 1 million rows and we ended with 2 billion
Trillion.
rows.
Okay.
So what do you classify that as if it's not technical debt?
It's just you outgrew the solution.
Just outgrew it.
Yeah.
Okay.
That by itself is not technical debt unless it goes back to those things that we talked about, like stability, productivity, you know.
Well, I mean, and that's where I kind of, from a relational database standpoint, when you go from 1 million to 2 billion and you don't change the schema or the model, obviously performance takes into effect.
Exactly. So let's take a moment on that one. The fact that you're finding yourself in that environment, we at least at the AWS don't consider that technical debt. But if it goes unchanged, okay, it'll lead to that. The question then becomes, what do you change it to? And are you more on the database side or on like the application? Database. Okay, so you can appreciate that if you change either the database type or the database schema, that by itself does nothing without the application folks do something to actually match the new end sort of data container solution, right? Okay, so that becomes an application rewrite. Again, we kind of consider it here as opposed to technical debt. But there are a lot of different ways of looking at that. One of them, and I don't know if this is applicable to you, is every once in a while when you find yourself in that situation, it might be time to actually think of a NoSQL database in terms of a sort of that relational kind of connection.
But again, that's a rewrite.
That absolutely is a rewrite. But by itself, everybody's going to find. Okay, most folks find themselves in that situation. It's just a matter of having to do something with that. But happy to talk about that more after this if you like. Because that's kind of come from a database background too. So ultimately what it means is you could be on-prem, you could also be on any cloud, but ultimately the cycle, the cycle that actually leads to technical debt kind of starts with a decision that you make in way of a trade-off of those things that we talked about. You know, basically you're trading these off for a specific reason. That reason generally is to satisfy some immediate need, some unexpected thing that came up, or some, I want to be careful how I say this, some entrenched practices at the organization that you're in. So here's some examples, just to kind of lay it on the table. So some competitor in your environment comes up with some really cool thing. Okay? Nobody's going to stop and say, okay, wait a minute, we'll respond to that later. We're going to do this other thing. No, you're going to respond to that competition event. The same thing with your larger customer comes and says, we have this new requirement and we need we need something new in the next 3 to 6 months. You're not going to say, hold off, I have 9 months of technical debt work to do, and then I'm going to, so we can all agree that there are conditions under which it's totally appropriate to say, I'm going to continue my technical debt. It just is. Anybody disagree with those? We can have a nice, long conversation, philosophical conversation about it. All right. And then there's a bunch of other potential options, including some leadership problems and, hey, I don't have the right folks with the right background, technical background to do this kind of thing in. So those kinds of things come into play. And then in a few minutes, I will kind of take this panel over to this other side, which is how do we crawl our way out of it? But to begin with, this is going to be a busy slide, and I promise, just give me a couple of minutes, it totally will make sense. If you look at a matrix of you're making a good, wise decision versus you're making an unwise decision, transposed over you did something, but you meant to do it, and something happened, but you didn't mean to do it. So if you kind of think of this kind of matrix, and then I'm going to throw a bunch of other names. So because, words mean different things to everybody. So again, think of rows here as it was the right decision, it was wise, it was prudent, it added value to my company or to my whatever work stream it is, versus it was a bad decision, it was reckless, it added negative value. Okay, so that's the rows. The columns are, I meant to do it, it was purposeful or deliberate, or it was visible to me, and then versus not. So that's the matrix. Okay? Now, guess which quadrant is the worst place to be? Sorry?
Unwise and not purposeful.
Yeah, like the red one, right? Because not only was it the wrong decision for you to take on that technical debt, you didn't even know about it. Like, that's the worst place to be, right? All right, what's the best one to be? It's really easy. It's the green one. Okay, so I know that I'm taking on technical debt, and I have a good reason for it. And we'll work through a plan for it later. But I'm purposefully taking it on. Okay? Now, these are the two, the oranges that are going to be interesting. So think of, I purposefully took on and accumulated technical debt, but it's an unwise decision. Versus this one, which is, if kind of looking back from the future, knowing what we know now, we would have done it differently. So if you really pragmatically think about this, if you're here, this is a future awareness. It's like connecting the dots backward. You don't know you don't know that you're going to be in this quadrant until much later. You won't have visibility to it. This one, you have immediate visibility to it. You see the difference? Okay, I see. Okay, good. Seems like everybody's getting it. Okay, so generally, obviously, we want to, everybody is going to go here, or at least try to. And so now here's the question. Why is it so easy for technical debt to happen? Because everybody carries it. There's no such thing as any app or any organization that doesn't have that. It's just a degree to which you're carrying it or you have awareness of it. So for example, there's a hairball problem. Anyone want to guess what that is? Maybe even you guys, since you deploy? Okay, so it's this. So it's just a mismatch of stuff that happens, and you cannot easily take the components out to do something with. They're all interconnected. And the moment you pull one little thing out, it's a house of cards. It'll collapse, right? Inertia. What do you think that might mean? Yeah.
There'd be those entrenched business practices.
Exactly. There's momentum. There's gravity. There's entrenched thinking. Analysis paralysis. Everybody knows that, right? Like, we don't need to cover this one, right? That's obvious. And then stakeholders of an organization or even a subunit then kind of struggling to align because that's, and we'll spend a little bit of time here, so I don't want to cover this too much. But what about that last one? Double bubble cost. What do you think that might mean?
Twice for the same thing, essentially.
Yeah, okay, thank you. So you have some stuff on-prem, perhaps, here's an example, you want to migrate that stuff to the cloud. You're paying for all the on-prem stuff because the servers didn't go away, right? You're still paying for electricity. You still have the bandwidth stuff. And now you're paying for the same thing in the cloud. So you basically double your cost. So here's the thing. The way to pragmatically look at this, because at the end of the day, like we just talked about what it is, how it happens, and all those kinds of things. But really, at the end of the day, who cares? Like at some point, you're going to have the so what question. So okay, who the hell cares, right? In IT or in the environment that we're talking about, there's generally three circles of functionality in terms of people. Either you're connected to the application side in one fashion or another. And so you're, for the most part, non-technical. Okay? You're an application owner, you're in finance, you manage products, those kind of, like you're a salesperson on the business side. So these are these people. And then all the techies are on this side, developers and QA and those kinds of things. And I don't want to say techies, but I want to more like on the development side. And then there are folks like you that come in and actually clean up the mess that these people leave. Because there's I'm sure you guys have your own like version of whatever the name is, but these folks say, here's what we want. Do it. These folks generate and create the code and everything else that goes along with it. And the technical term is you lob it over the fence to these people and then have these people worry about all the cleanup and take on all the blame. Like that, this is you never win in this circle. You're under attack from these people and from these people. And I think you know what I'm talking about, right? Okay, so that's just generally how it is. And so if you look at it from the specifics of each one, these folks on the application side and on the finance side are super incentivized to worry about these things. Those things are, you have a bunch of users, right? You have a bunch of clients. You want to keep them happy, but hey, you want to keep adding new features. You want it fast. You want it cheap. You want to release it now. You want it to look good. Those kinds of things. Okay, those are obvious, right? On the development side, like the number one thing everybody asks for is that write good code. Okay, and that's kind of, we'll cover what that means. But write really good code. And then everything else that goes along with it. So what is good code? Clearly, it needs to work, right? It needs to be efficient. You want it secure. Nobody wants to be hacked. You want it to be not buggy. You want it to perform fast. And you want, for God's sakes, that developer leaves and somebody else shows up. You want that new person to be able to look at the code and actually understand it. Because otherwise it's completely worthless. So I defy you to tell me if there's anything else beyond these for writing good code. That's ultimately literally what it comes down to. And then these folks, if you're in DevOps and you're in platform or operations, the last thing you want is to play with old technology. Okay, nobody wants that. And you are going to be held to standards that you're not completely in control of. For example, uptime and business continuity is your problem, irrespective of how bad the application may be, right? And nobody wants to get pager duty in the middle of the night. It just isn't in the cards, right? Okay, so what it comes down to then becomes all these different circle of folks. We can have basically a fight about all this, or honestly, if you really think of it pragmatically, in an organization, we all want the same thing. Nobody wants the company reputation to be bad. Everybody wants to have secure code and application. Nobody wants to get hacked. Everybody wants to be able to innovate. You want it to be stable, all the other stuff. Like we have so much in common among all these people. And what we do is These people lob it over. These people lob it over. You're now responsible for all this. You're going to have to blame somebody at some point, right? Because like, it's just life. And there's this infighting happens. So how do you fix it then? It's sort of a two-phase approach. I'm not going to cover all this in sort of exact detail, but just kind of, a visual representation journey of how this all works. It's a step-ladder problem. You can't fix what you can't admit to. I have to say, okay, I got a problem, and that's what I'm going to do, right? And then you come up with a plan, and then you execute it, and then you measure the success level of it. So, from this perspective, that the quadrants that we saw, obviously, we need to move to the deliberate one. It's just an obvious one. And there's a huge difference between what is a good debt and what is bad debt. It just is. It's just reality. Because that's intentional if it's good. And a bunch of other things, we just talked about those things. Whoops. But I wanted to, But I want to concentrate here a little bit. So when it comes to planning for reduction of technical debt, there's a sort of if you think of it, there's a matrix of a balance of speed, value, and outcome. Like everybody knows you can have it, we've all heard this. You can have it fast, you can have it cheap, you can have it good. You can't have all three at the same time. You can pick any two of the three, but you can't have all three. And it's the same thing here. There's a balance of you can't fix everything, but you're going to have to pick a few things. And the way that works is that you deliberately have to, and this is sort of the pragmatic side of approaching technical debt, which is how do you do that when we all have day jobs and we don't need more crap? So the pragmatic way is that you have to deprioritize one thing in order to have enough time to prioritize something else and then decide to give up another thing. It's sort of three things coming together. Two of those are more immediate decisions, and one of them is a long play. Okay? So, for example, you can say we were planning to, and this is like almost literally one of the decision-making points that I was part of when I was with a startup software company some years ago. So we had decided to do some cleanup on our UI. Okay, but we purposefully deprioritized that in order to prioritize adding an API and moving it to the cloud. So deprioritize one thing, prioritize another thing. Those are immediate sort of decisions. That doesn't mean they're going to get done tomorrow, but they're more on the immediate horizon. And then you give up one thing. That's the long play. Like, we decided that, okay, in 3 years, we're just going to get out of the hardware business. That was just what we had to decide as a small software organization. Or we want to reduce our reliance and our burden of licenses over the next 4 years. And we came up with a plan starting with Oracle. So this is a much longer play in that context. If you think about that. Just curious, you guys, I assume you have sort of on-prem and cloud presence, right? Okay. Yes, no?
Depending on the customer. Yeah, so we're consultants, right? So we're doing.
Okay, got it.
So
okay,
we work with a wide variety of customers. So yeah, some will have a footprint on-prem and also in the cloud.
Okay, fair enough. Okay, That totally makes sense. One more question. Any of them multi-cloud?
Yes.
Okay. Is that 50% less or more?
In my experience, it's less than 50%.
Okay. And we'll talk about that in a second. Okay. So that's sort of the plan side of things. And then here's the kicker. At some point in time, you're going to have to execute on some plan that you came up with. So who has heard of Cloud Center of Excellence? Wow, okay. Do your customers have them? Or do you know about them because you pitch it? Perfect, okay. Is it more on the centralized side or decentralized side?
T.
Centralized and IT. Okay, fine, okay. Anybody else? Okay. So, one of the things that we've learned, and I want to be careful how I say this, AWS was one of the first sort of public clouds, so one of the things we've learned, perhaps ahead of the other public clouds, was that unless there's some centralized wrapper around the asset allocation and the guardrails and everything else that goes along with it in order to democratize technology for all of the folks in an organization, or even, quite frankly, around enabling people to do innovation, is to have a CCOE. So these are individual folks that come together, each one with very specific domain knowledge and experience that determine what is possible, what is allowed, and put those guardrails in place and create automations and other things and be the final arbiters of any questions. So that is one of the really strong plays that technical debt can seem to benefit from. Because without that level of sort of arbitration and umbrella, it's going to be hard for everybody to decide, okay, well, what's next? What are we doing? So that's that. And then obviously, I know whether you like it or not, upskilling the workforce comes into play for reducing technical debt. And then a couple of other things. One of the things we like to say at AWS is that relentless automation. If you don't have to think about it, it just works. And it just gets done, and nobody has to worry about it. So now, the last item here, again, like I said, I don't want to cover every single one of these things, but here's the last one. I want to cover this one a little bit in detail because this is really ultimately what technical debt consolidation, if you think of it that way, implies. So who has heard of 7 R's? Nobody? Okay. How about now? Anyone? Okay. So this is when you take a bunch of apps and workloads. For example, if you have them like on-prem and you decide, what are you going to do with those things? I'll cover this in a minute, but think of, you can, for example, say, hey, some of my apps I'm going to retire. Some of my apps, I know there's old technology and other things and blah, 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 but I'm just going to have to retain. And then I'm going to do a bunch of other things with the rest of them. I'll cover this in a minute. Because once you make a decision for all of the apps and the workloads, the very next natural progression is, well, you're going to potentially, if there's migration involved here, it's not the case in every situation, but if there is an on-prem to cloud migration, then you're going to have to go through this kind of exercise where you have to first, what we offer at AWS is a lot of different assessments that helps you develop a really nice, clear picture of what are the options for all the different workloads and applications and what to do next. So you can take advantage of that, but here's the big one. We have a lot of incentives called MAP, Migration Acceleration Program. We literally give you money to move your stuff to the cloud. Okay? That's like even up to 25% of the entire cost of you moving that workload or application to the cloud. Excuse me. And we're happy to do that. So you take advantage of all of those things that are free to you. And then once you migrate, let's just say it's an application workload. Excuse me. The question becomes, now what? Because if you migrated your application, a lot of times you carry the technical debt with you. All you did was move it from one place to another, right? And it's not until you do this kind of thing that you can actually pull yourself from under the weight of the technical debt. So, excuse me, for us, modernization could be any of these items here, but let's just sort of talk about a couple of them, especially you guys in sort of the DevOps sort of space, if you will. Just curious, I don't need like exact information or detail, but what are some of the DevOps tools that, especially if you're consultants, you've come up with, you've seen at your customer sites that you use that you might want to do something different or use something different as a tool? Like, what are some of the DevOps tools that you've seen, especially when it comes to CI/CD pipeline and deployment and those kinds of things?
Yeah, I would say, if they're still using Jenkins, depending on where they're at in their, life cycle of their company, I think Jenkins is, a little dated at this point. There's so many much more cleaner GitHub Actions, code deploy with AWS. There's modern ways to do deployments that don't rely on having a standalone Jenkins server as one example on my mind.
Okay. You guys?
First
Anything?
thing that came to my head too.
Okay. Here? Okay. So what about like Chef?
Chef is it's still around. I still wouldn't, if you're starting a new project and you want to use Chef, Ansible, I would probably try to talk through that.
Okay.
And, just like I would really talk through about, not really related, but if someone's really thinks they want Kubernetes, you really have to think through that of why you want to run your workload on Kubernetes versus.
Well, actually, that's perfect because so what are you steering them toward?
My personal preference in that conversation is to, Kubernetes is essentially running a cloud within the cloud, and you lose some of the benefits of those integrations when you run Kubernetes even in EKS and Amazon. Whereas if you just use their container service, it integrates nicely with all the other AWS services. So you're losing some of those really nice, well-rounded integrations by running your workload in Kubernetes. You can do multi-cloud, but that's not easy. And
actually, we're going to get into that.
Yeah. So
there's we can discuss that for 2 days.
Yes.
Yeah. Okay. Anything else like in way of like cloud native resources or services for anybody else? And cloud native could imply, for example, you go from SQL database running on EC2 or on bare metal or even VM to like AWS RDS, those kinds of things. Anything at all, especially for you since you're a database guy?
Yeah, I mean, some of the workloads that we've migrated up originally, and this is Azure side, so not to spoil that conversation, but a lot of the lift and shift that we did was just straight to IaaS because it was much easier than just going to like SQL paths or anything like that, because you lost SQL agent and some of the automation and SSIS and this in the early days.
Yeah.
So a lot of the times we just went straight from, on-prem to IaaS and just let it run. So.
Yeah. So just out of curiosity, that very first step to the cloud, that very first step to Azure, without doing anything else, that initial lift and shift, what was the sense of, did you carry the technical debt with you?
Oh God, yes.
Or did you increase it or decrease it?
It actually depends. In some cases, we decreased it because it was just the legacy hardware that it was running on. We're talking 10-year-old servers that we just needed to get off of. So that decreased debt there. In some cases, though, moving those particular applications, now you had network issues because now you're going across the cloud to get to access to your data. And if you didn't properly move the application stack along with that, then a whole sorts of mess there.
Okay.
So there's gotchas one way or the other.
It can go either way. Yeah, actually, I was going to say, but I don't need to add anything to what you just said. So it's exactly right in that going from on-prem to a cloud could go in either direction. But honestly, exactly as you said, other than sort of the hardware side of things, you're carrying the technical debt with you, and a lot of times you're actually adding on top of it. That's just a pure lift and shift migration. By itself, there's more to it than that. So you really need to worry more about the rest of the stack, as you said. So yeah, thank you for that. So that's exactly the experience that we see, because CapEx went into OpEx for a company, and they're like, okay, perfect. So like now nobody from finance is worried about it, and they don't care, right? It just got done magically. It got wiped, off the balance sheet. It got wiped off. So like, okay, we're good. So but then everybody else is suffering through that. Okay, so there's a modernization sort of portion to the picture, and then finally, even when you modernize, the problem is at some point in time there's some level of optimization that goes with it. So here's like a perfect example. If you go from some like monolith application or some old application stack, and you move it, here on-prem, you move it to the cloud, and you carry most of the debt with you because all you're doing is just basically just using the resources of that cloud. Ultimately, what happens is that here's what we see a lot of, and I'm just curious if that was your experience at all or not. What we see is there's a single server, because it's sort of an older sort of technology and more like monolith, there's a single server on the application side and a single server on the database side that run this app. And what happens is that, hey, once a week, once a month, some process has to run against this app, like end of month accounting or something like that. That thing kicks off, I don't know, Friday night at midnight, and it runs till noon on Saturday. It needs a certain amount of CPU, a certain amount of disk, and a certain amount of memory to actually make that completion happen. But here's the thing. In order for that to work within a 12-hour window, you have to have this huge compute and this huge memory and this huge network, which means you're running the whole thing all the time like that, just because once a month or once a week for 12 hours, the thing has to happen. Because the problem is you can't separate it, you can't right-size it. And so, but the thing is, once you go through this exercise of modernization, now you might have cloud-native serverless database at the back end where the database just manages the scale as more stuff comes its way, right? Or you did a few other things here, and then you were able to separate the application stack, at least on the apps, whatever it is on the outside of the database, because it could be the app, it could be the web server, whatever combination you want to call. But now you can say, I can scale that up or down, like what you were saying, in terms of add more resources, add more servers, EC2s, containers, whatever it is, to meet that required 12-hour journey of get stuff done as fast as possible. But then the moment that is done, I will go back and right-size this thing and scale it right back down. So this journey is not the end. This is the end. The modernization, the optimization side, this is where everybody should be heading. The problem is almost everybody sort of stops somewhere halfway in between here. And that's the issue with technical debt. Did you have a question? Okay. Yeah, like we just talked about auto scaling and those kinds of things. Like those things matter. So we were here. So again, you trade off a bunch of stuff, a bunch of really important stuff, because of some immediate need, or perhaps unexpected need, and here's some reasons. But then the journey gets completed once you can migrate. Again, this is only for AWS. Migrate from on-prem to a cloud, and in a minute we can talk about that, because there could be reasons why there's actually a funny thing that we talk internally about at AWS, is that, and in a minute I will talk about it, which is there are certain conditions where we're totally happy if the workload doesn't come to AWS. So we'll talk about this in a second. So you go through some migration portion of it, because you carry most of the debt with you. We just talked about that. And then you go through a modernization journey where you kind of do a bunch of stuff, and then that's not complete until you actually do some optimization where you truly appreciate the right sizing and the scale variations of the cloud, because that basically completes the circle. Again, because something else is going to happen, you're going to say, oh, well, whatever, and then things are going to slow down. You're going to have to go through this process again. So those 7 R's that I had a few minutes ago, so rehost is the biggest portion of it. Generally, the implication here is that you take a compute resource on Azure or on AWS, which if it's AWS is a combination like EC2 or maybe Lambda. You put the app on that compute resource and just sort of run it. That's the first migration step. Yeah. And that's most of what we've seen happens on the AWS cloud. Every once in a while, you do a sort of there might be VM, so you do VMC on it, or that sort of thing. But that combination pretty much covers the first 50% of the journey. Like but remember, you carry the technical debt. It's just that you 50% of the way to actually completing the process, because this was some work for you. But then, so remember the word rehost, because we're going to come back to this, because this is like a resource running on some application running on some compute resource. Remember the re-platform, which means you might take a SQL database, for example, running an EC2 instance, and say, you know what, I'm going to do some minor things, and then I'm going to have I'm going to convert, or I'm going to migrate that database, that is a physical database, on some virtual machine to like AWS RDS. It's managed. I'm just going to let it get handled there. And then also remember refactor here. We'll come back to this in a minute, because just so you can see the sort of the percentages of what we've seen on the AWS side of things. We don't need to talk about that. But generally, modernization means you loosely couple your stuff, whatever that is. Like, you can separate the the different components of your application stack into, sort of a fan-out architecture. I'm going to talk about that in a second if I have time. Yep. How much time do I have? Okay. It'll be. I'm not going to bore you too much, but thank you. And then you add some event-driven architecture to it, and then you make it fine-grained. And this all makes sense in a minute. So that's the whole modernization journey. So Windows. Well, obviously on your side, but I assume you guys see plenty of that, right? .NET. I assume you see plenty of that. Is that the application stack they were talking? Okay, perfect. So let's kind of go through this mental model. So here's an example of the things that we can kind of get together and talk through and map out and have a plan going forward. So if it's a .NET legacy or .NET framework, means you're stuck on Windows, right? It's not like, you have to kind of go into the .NET core area before you can go and kind of at least take some components of it from Windows to Linux, right? Everybody knows that, right? Okay, so if you're .NET legacy and the application is constantly in use, so let's just consider that one. Look at the columns. You can rehost, remember, you just take your application and put it on like some virtual compute like EC2, or you take your Windows server and you sort of containerize it, just because that way at least you contain all the stuff, especially if it has a lot of old stuff associated with it that might not even run on an EC2 environment. And then we can talk about Linux and those kinds of things. So if you have at least just curious if what you folks might actually say in response to this. If you have an application that is old .NET legacy, which one of these things is available to you? Is Linux available to you at all at that point? Okay, no. So really, you're stuck only with these two options, right? Okay. Let's look at these guys. You have the ability to remove the Windows dependencies, and you want you can resolve the .NET framework, which is locking you into Windows, and you can also remove the dependencies. Where do you want to be, on this side or more like on this side? Just curious. There we go. Like, why would you not do that? Because on AWS cloud and not quite Azure, the other cloud, the compute charges for Linux is a lot less than Windows. And you have a lot more options to actually do cool stuff with, up to and including the most recent insanely fast and efficient chipsets really are only available for Linux, not for Windows, in the cloud. So you really are working toward that. Plus, nobody wants to pay licenses. All right, so one more just as an example. There's a monolith application. It's sort of very rigid. You can't fan out the different components of it, but you want to sort of split that. Are you looking to stay long-term here or here? Left or right? It's a trick question. Take a guess. There's no right or wrong answer, just take a guess. Okay, right. So now here's the question. But you want to split it. So are you more thinking about Linux container, or you're talking about sort of microservices on Linux container, or you're just talking about sort of, Linux sort of direct? What do you think which direction should you be heading? Fair enough. Because here's the thing. If you want to split the monolith, you really are looking at microservices, right? Serverless microservices stuff. Which means you don't want to just take this thing, this .NET framework, go to .NET Core and just, excuse me, go to Linux and containerize that and you're done with it. Like that didn't really accomplish the task. You're hoping to run microservices. So you can do microservices either in Linux or without a container. But that's the direction. You're fanning things out so that you're not stuck with the entire application stack in one big giant nonsensical, monolith. Excuse me. So that's one example, like the kind of things that we can work with you on. Bunch of references here. Here's another one. Who has heard of strangler fig? Okay, so this is a tree that has the tree trunk, and I can bring it up, but it doesn't matter. We can just talk through it, and that has the capability of some branches as the tree grows, come down, go into the ground, plant roots, and eventually when the main tree dies, they will take over, essentially prolonging the life of the tree, of that organism, right? Because it, you took one single thing and you are able to replace it with other things around it that eventually will take over. So if you think of a monolith app, a lot of what the cloud can help, the public cloud can help with is, for example, again, it might not be the case in every situation, but take an on-prem, really old monolith app, and it's almost impossible for you to say, hey, we're going to migrate this thing in these steps to the cloud. There are too many dependencies. Like you said, you can move the database, but then the application stack is not moved or some other data thing is not moved. And now you just introduce a sort of a network latency dependency that you don't know what to do with. Right? So what this concept implies is that you can keep this stack here on-prem. On the cloud, you can add an API, and APIs on all of the clouds are ridiculously powerful. And you can kind of tell all of your users or tell all of any other sort of consumer that uses this app to now go here. All this API is doing is redirecting it back. Okay, so that's sort of step number one. Okay, then you say, okay, I'm going to take a component of this and move it to the cloud and do something else. And the API, every time, for example, the user is asking to check my balance, can go over there. But every time the user is asking, use the new interface, it's going to stay here in the cloud and get connected to this new thing that I just generated. So it's like a strangler fig tree in that that's the old tree trunk, and then you have these other branches around it that eventually you're able to use to redirect all of the traffic and then eventually get rid of the monolith. So it looks sort of something like this. You have this monolith here, so this is on-prem. You simply put an API in front of it. Yeah, but there's a bunch of stuff here like, web application firewall and stuff like that. Well, whatever. You can ignore all of that. Basically, you just put a facade in front of it in the form of an API. The API, all it's doing is redirecting it right back where it was. Okay, step one. You just put a storefront in front of it. Then you say, hey, I'm going to add an entire ecosystem over time on my own time as I'm able to do. So for example, I might be able to take this portion of that monolith app and bring it here and rehost it. Remember, like put it on EC2, like literally take some steps and take the pieces and put it here. So for example, the API might have a, blah, 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 www.com, so, whatever, slash, again, check my balance. It goes over there. It's still back in the old monolith. But slash analyze my spending or something like that, it now kind of comes here. And then you can also take another one piece here, and if you can't sort of rehost it, you can kind of refactor it, like containerize it or something. So over time, you can kind of break away from the components of that old monolith and do something with those pieces in the cloud, either host them directly on a virtual machine, containerize them, even to the point of introducing serverless components. And over time, you can get to a point where you say, okay, so because the API that is in front of all this is redirecting all that traffic, so you can easily just redirect the traffic, and at some point in time, you just get rid of that one last piece, either gets retired or gets moved, or some such thing. So we can kind of work through these kinds of things with you on the AWS side, just to kind of pave the path forward for what to do with that technical debt. So here's some other information and links. Okay, almost done. Couple warnings. Especially for you guys, have you ever found yourself in a situation where a client might say, I want my app to be able to be written in such a way that I can actually port it either in this cloud or in that cloud? Like I want to have the autonomy and the ability to actually go any direction I want. Okay, so we believe that's a myth. I know it gets done, and you probably already have done that, but we have very strong opinions about this, to the point of when I was saying earlier, there are actually conditions under which we say, we truly believe that our customers should select one primary cloud for every individual application workload or sometimes organizational unit. It didn't say, I'm not saying one only, but one primary. Yeah. The problem becomes that the moment you say, I want to be able to run it here and I want to be able to run it there, you're lowering the standards to the lowest common denominator between the clouds. And I'll talk about this in a second. Even, quite frankly, sometimes organizational units, to the point where we kind of, because the engineers have familiarity with certain things. They're not fully versed in two different clouds. One cloud takes precedence for them. Right? It's just a fact of life. So now you're kind of, everybody is just getting headaches and getting whiplashes as they're trying to switch clouds. So this is what I was saying earlier, in the sense that sometimes we at AWS say, we really believe this so much that if that means somebody is going to choose some other competitor, that's okay. Because this is a kiss of death for us, we believe. So here's a mental model that we think about. So think of how you might approach a project. So you might say, hey, I have an idea for an app. I understand what the design should be. I'm going to preserve my original vision and intent for that app. Now, once I've done that, I'm going to look at the cloud that I'm going to move it to. And I'm going to see what the behavior of that platform or the services that cloud has. And then implement it that way. Like you maintain the original vision of what the application that you want it to do, and then you look at the capabilities of the cloud to actually implement it. The wrong way of doing it is if you first look at what the cloud can do, what are the boundaries and the limitations of the services that the cloud can provide, and then I'm going to kind of fit with, kind of wrap my application, what my original intent and vision is around that, because that never works right. So think of this mental model with me. Amazon.com, okay? You go in, it knows who you are. If you haven't logged out, you look at a bunch of stuff, you select something or multiple things, and then you purchase. Think of the million things that have to be orchestrated behind the scenes after you purchase it. Okay? First, we take your payment, right? That's a whole orchestration by itself, and then we send you a notice, some sort of a notification that we accepted it. Then we look at what you've selected. Not if you have 5 things you've selected that you just purchased, not all 5 are in the exact same warehouse. And not all 5 have to come from the same warehouse. We're orchestrating proximity, delivery time, where it is, backups, backlogs, all kinds of things. And so this item might come from that state, this next item might come from a different state, the orchestration of that, bring it here, send notifications to each one of those warehouses. Somebody's going to have to go pick that thing up, right? And then send another notification to the delivery folks where they have to pick up in trucks, transport it somewhere else, and then deliver during the last mile. There's like a million pieces of orchestration tasks. Like everybody can appreciate that, right? Okay, so if you were going to write that in a way, like I know it's a million tasks, but conceptually it's kind of simple. Like you understand what those things are, right? So think of if you had to write the app so that it can run on Azure and on AWS, and I will tell you the reason. Who knows Amazon SQS? Simple queuing service. Okay. So you know that there's a bunch of producers put a bunch of data in this queuing mechanism. A bunch of consumers come and grab the data, right? Okay. So in this mental model we just talked about, this whole Amazon.com thing, you're notifying the warehouse that somebody has, this is an item for this specific customer that has to be picked up. So some information, some data goes into the queue. Okay? There's a consumer that comes and picks it up, reads the thing, and does some other thing with it. Okay. Well, so think of you want to prevent double order entry. So once a consumer picks it up, you want this thing to go away, right? Until you get confirmation from that consumer that I did that other thing, I send notifications, I updated other systems to come back and say, I'm done, right? If it doesn't ever come back, you want the data to come back into the queue again, right? So Amazon SQS does those things. So it has something called a visibility timeout. A consumer comes and picks up the data, it goes away, it's hidden, and if it doesn't ever get confirmation, it's going to come right back. And if it doesn't get completed after 2 or 3 tries, it goes to something called a dead letter queue. Somebody gets notified. There's a problem. For a long time, one of our competitors, in their equivalent queuing service, they didn't have a visibility timeout. So if you're going to write an application that's going to run on both clouds, think of what that means. I want to make sure that it doesn't get double entry, right? okay, if I'm on AWS, the service is taking care of it for me. Like the cloud is taking care of it for me. There's an invisibility timeout, there's a dead letter queue. Doesn't get picked up, somebody gets notified. I don't have to do anything else. If I was in the other one, I'm going to have to write code around that. So I'm going to write code that says, go pick this up. And by the way, don't let anybody else to come and pick that up, right? Which means I'm going to have to put like a tick mark somewhere in some data. I'm going to have to create a database to keep track of these things. This thing got picked up by this consumer and at this time. So, and then I'm going to have some other process that comes in, looks at all these rows of data and says, okay, which one of these things have been like an hour? We didn't get a confirmation, so give it to somebody else and eventually do something with it. So now you have to like write code and processes around to creating a separate database that keeps track of all those things. Right? So now you're lowering the standard of your application to run in both. Pick a cloud and go with it. Because if you're going to do this for both clouds, even if you're running it on AWS, you're still then, because you didn't take advantage of the service that that AWS is offering you, you have to create a database and run it on some EC2 or run it on like cloud native RDS or something like that, right? Extra thing that you didn't have to do. Even on the competitor cloud, you still created extra steps, because if that's their limitation at that point in time, what you can say is, you know what, I'm not going to do it this way. I'm going to use individual queuing systems and don't ever let this consumer to ever see the data in this queue. I'm just going to map it one-to-one. You still created extra work for yourself. So this multi-cloud, I'm going to take one application or one workload and I want to write it in such a way that it runs on more than one cloud, has never worked out as far as we are concerned. So I'm just actually curious, what is your experience with that? Because since
So just funny story. So the company I previously worked for went through a merger. Both companies used one or the other. And as the merger was going on, finance and the powers that be thought it would be a great idea to just put them into one. So we had to go through the exercise of trying to fit all of our Azure stuff into AWS. AWS came back and said, no, don't do it. And so we didn't.
yeah.
So I just thought it's funny that you bring it up. We originally had gone through the exercise, and in the end, it was just, don't bother.
Yeah.
So.
Yeah. Yeah, actually, thank you for sharing that, because that kind of was my point. Yeah.
Yeah, like hit the nail on the head with this. If customers that we're dealing with from a partner standpoint, talking multi-cloud, we're gonna tell them that's a myth and really just ask a lot of questions to help expose all the challenges of that. A lot of people again think Kubernetes is the panacea of multi-cloud,
right.
But it's not.
Right.
And there's always edge cases. I can be convinced that you want to run a Kubernetes cluster to run a third-party application that has a great Helm chart and support. Like, sure, that's great, but let's keep your application workload isolated from that, because I'm hard-pressed to find, I've never seen it in reality, just to be blunt, that's an app that truly runs on multiple clouds. I've seen companies do different things in different clouds, which I think, again, that's valid. That's valid. So, yeah. A lot of people, a lot of high-level decision makers have like the idea of multi-cloud, but they don't seem to understand what the technical debt and the cost of actually making that a reality will be.
And a lot of times it comes from the angle of we want to be able to protect ourselves against one or the other, right? But you've now lowered the standard to the or lowered the level of the app or the workload to the lowest common denominator in such a way that nobody's going to win in that regard. I'll let you speak in a minute. So what we, exactly as you said, what we consider is like, take an application, pick a cloud, even if it's not us, that's fine. So that's valid, okay? It's also valid if you say, my application and data stack is in one cloud, and I want to run my analytics in another one. We don't like it that much, but it's still valid. Like it works. And then if there's mergers and acquisitions and those kinds of things, that other company might come from a different cloud, which is also okay because they have expertise there, and you can't readily prove to anybody that other cloud is not better than this other cloud. Just that totally makes sense. That's a valid separation in terms of workloads, organizational units, and those kinds of things. Yes, sir.
Yeah, I was just going to say another thing beyond this multi-cloud that I've seen, people fall into is this fear of lock-in with any cloud provider,
Yes.
and that they don't. It's not necessarily multi-cloud. They just want to be able to get out of the cloud if they want, or they want to be able to be in a hybrid environment where it's not even multi-cloud, but it's on-prem and in the cloud, and it's just kind of interesting that they perceive cost benefits of being able to be in a data center at times, but then it's really you're increasing costs so much more by not taking advantage of the
And
managed
lowering
services
the
and cloud
performance
products.
of the app in the first place,
Yep.
along the way. Yeah, you're right. Because I can't tell you the number of times before I was with AWS, the number of times I heard some CFO that I had a connection with say, well, I don't want to be locked in because every time I am negotiating the next 3-year deal, I can pin the two against each other and say, well, I can easily take it to the other place, which is absolutely doesn't work.
To take lessons they've learned from like licensing costs and apply it to the cloud.
Yeah. And they all have different licensing costs in the first place. So it's like, it's not even one-on-one. Okay, anything else on this one? Yes, sir.
So how do you deal with the container team and the technology stacks? I'm not a container guy, so AKS versus EKS versus Docker versus Kubernetes or OpenShift, right? They're all different technologies. If you have a small team, how are you dealing with, I'm going to put application A in one cloud, I'm going to put application B in another cloud?
Yeah. Well, here's the thing: if the workload is containerized, it should be portable. Like that's the advantage of having it containerized. Because why else would you do it? Like you're containing this whole thing, you can just take this thing and put it somewhere else. On-prem, AWS, Azure, GCP. It can go anywhere.
AKS and EKS are completely...
But all the major clouds have ways of dealing with those other containers, even if it's a minor bit of work. So like Amazon has EKS. It's essentially Kubernetes on Amazon, on AWS. Like it ultimately doesn't matter in the grand scheme of things. So if you recall, one of the slides that I had on the modernization side is open source. That's open source. We'll accept it. We'll work with it. So it's not that what you're describing is a conversation with those folks from a different angle of what is the value of having this thing containerized or on EKS versus where can I take this EKS that already this Kubernetes that already exists? We can take it. So can Azure and so can GCP.
Whatever your team's preference is, right? I mean, if they have the expertise in AWS,
In Docker.
yeah, and Docker, or
Yep.
they have to figure out which cloud is the one they prefer to work with, and
All three clouds will take them.
Take it there, especially if you have a small team, because you gotta pick a horse and go with it.
Yeah, happy to talk more about that, but yeah, we definitely have seen that too. In that, well, it's Kubernetes, and we're just going to keep it on-prem, or we're going to keep it in this. Well, no, all three cloud providers will be able to handle that. But exactly, it's just a matter of then what? Like, what are the peripheries? What are all the different supporting ecosystem apps and consumers and producers that have a connection with this containerized app? And what do you want to do with those? All right, so if I can, okay, so I'm just about done. So, all right, so really quick, all the clouds have this. I'm AWS, so I'm just going to talk about these. We have a million things, million programs to be able to help in this migration and modernization. So just sort of mentioning a few, putting red hearts against some of these things. We literally pay you money to move application stacks, migrate that. We have something called EBA. Has anybody heard of that? Okay, so it's a hands-on workshop. So for example, you have Kubernetes, and you want to be able to take that and actually do something with, go more cloud native and those kinds of things. This is a 2 or 3 day workshop. You bring your folks who are the experts on that application stack, on that workload or whatever. We at AWS come with our expertise in whatever domain that is. 2 days, we sit down, we decompose that thing, we create the right components, and we have it ready for unit testing. So in 2 or 3 days, we get done what almost 12 months of work would have required to get to that point. It absolutely is free to you, but you pay in resources and time and everything else that comes with it. But these the EBA program accelerates things just forward by miles at a time. A couple other things, I'm not going to talk about that, but if you have anything in AWS, we have what we call security, resiliency, and optimization snapshots. So we can kind of go through that exercise with you. We just talked about a bunch of those things. We can kind of like map things out and help with that. I will also, there is also, whoops. Okay, here we go. The blue ones, we have a couple of assessments where we can actually figure out where the maturity level of the different groups involved, whether they're developers or application owners, DevOps folks, and then kind of give you a sort of a prescripted guide going forward for, getting rid of the technical debt. We have a bunch of workshops. We have a bunch of immersion days, hackathons, and has anybody heard of a game day? Have you participated in one? Say more about that.
Yeah, I mean, they kind of come up with fictitious scenarios. You kind of compete with the team, solve it, and it's very gamified. It's a lot of fun. You learn
a lot. So you pay nothing for the whole environment that you're playing with, and you learn a lot. So we give you specific scenarios, and then you have to solve them. And through that process, you learn exactly how things work and how to deal with latency issues in AWS. How do you potentially make the application response faster by putting up a CloudFront in a different region so that things are cached? There's just all kinds of things that come into play. That's really cool. And then a bunch of places where you can find information. And if you like, you don't have to do this. If you like, we will love a survey. We collect 0 personal information of any kind. Happy to answer any questions or just have side conversations. Thank you so much.